Thanks everybody for joining. Good morning, good afternoon, or good evening. This is the uh, inst December 2nd or 3rd instance of the Antrea community meeting. And for today, we have a presentation from the CNCF mentorship program. I don't know if I got the name right or not. And this presentation will be given by Hemant, who joined the call and is ready to deliver his presentation. I don't have any other topic in the agenda, so if there is anything else that we would like to discuss for today, perhaps we can do that after the mentorship program presentation. Um, so have I done a mistake? Am I right? We have the mentorship program today, right?
Yeah, that's correct.
Perfect.
Emmett is on the call, and he did his
Okay.
mentorship with Chan, Yang, and me. And I know he has a video recording that is going to walk us through that shows the work he did as part of this mentorship program. So,
Okay.
Emmett, whenever you're ready, feel free to share your screen and yeah, walk us through your project.
Please go ahead.
Hi, everyone. It's a pleasure to be part of the community here. So let me just quickly share my screen. And please let me know if you can see my screen.
Yes, we can see it.
Okay, great. So, hi everyone. This is the LFX mentorship program that I went through, and I worked on the Antrea issue, which was basically application level DNS caches for the FQDN-based security rules. So, I've divided this presentation into a couple of sections, which will be introduction, a basic idea about the FPDN network policy, which is the feature of Antrea CNI plugin. And then we'll discuss about the issue that we had for the mentorship and the solution, a couple of PRs that we worked on, and finally the demo. So, a quick introduction. My name is Hemant. I work as a Python programmer in a company called Aspirify, and I did my higher education from the Indian Institute of Information Technology, Allahabad. And these are my wonderful mentors, Anteren, Yang, and Chen, and they have been very, very helpful throughout the mentorship. And I'm thankful to them for all this effort. And um, this is the so basically we all know that FPDN network policy is a feature that was incorporated in Entria, and basically we understand that it supports the Entria supports the FQDN based network policies for cases where the DNS names rather than the IP address are used to define network policies. So generally we use IP addresses or CIDRs or for network policies, but this was an added feature. And accordingly, Antrea programs the needed data path rules for the movement of traffic towards these FQDNs based on the results that we get as part of the DNS responses. So this was the feature actually. So the issue was that it basically started by an observation that was quoted by Shang in the issue. So basically, what had happened that in some Java applications, basically they cache the IPs for some periods of time which are longer than intended. They were caching it for longer than intended because there is a specific setting in JVM which basically enables the DNS cache with a configured TTL instead of respecting the TTL received in the DNS response. So, for instance, if the DNS server sent a response wherein they had the response had a TTL value of say 5 seconds or 10 seconds, but due to this setting which is present in the JVM, the application actually ended up retaining that IP for a longer period of time than the intent of say 5 seconds as was received in the response. So because of this, what happened was the application continued to hold or cache the expired IP, and in the meantime, um, uh, so it was basically because it continued to hold the expired IP. it hindered the communication to the concerned FQDN. So what exactly happened was, see, these are some of the steps, just to reiterate the issue. The pod made, say, a DNS query for the concerned fully qualified domain name, and Antrea, as expected, it worked on the DNS response which it got as part of the query, and it mapped the domain which was queried for with the corresponding IP address which is got in the response. Now, the pod connected to the IP because, as we know, the Antrea had picked the IP from the response, and it had created a data path for it. Also, Antrea had maintained it in its cache. Now, respecting the TTL in the response, after some time, say about 10 seconds or 5 seconds, Antrea refreshed the Aquitian resolution by, so what happened was that, and when it got the response, it found that there were some discarded IPs, and therefore it acted upon it and removed the concerned data path rules. So now, since the data path rules have been removed, the pod then attempted to reconnect using the same FQDN, but because it had I mean, it hold on to the expired IP. Therefore, it completely skipped querying the DNS for the IP because of its own cache. And the in the previous slide, we saw why it did that because of the TTL thing. So, and therefore, ultimately resulting in the failure since the IP was no longer valid in the data path of Antrea. And because of this, the pod was not able to basically communicate with the domain, the IQ domain. So the solution that we came up was that we should basically uh, uh, come up with a configuration value. There were other cases also, like we could set up, matlab, other things, but this was basically a more detailed, viable solution for this instance. So the solution was basically that we should create a kind of a minimal TTL configuration, which is configured by the cluster administrator, and that value could possibly a maximum value or a value that the cluster admin finds suitable as per their need case. And so basically it would basically avoid requiring developers to do a couple of things, for example, say disabling their DNS cache altogether, or to forcibly respect the TTL in the DNS response that they are getting. So that would have been, something that the developers would have ended up doing on their end. So, and by basically having a min-TTL configuration, it solves the problem for both the cases. I mean, for both the parties. So we named this min-TTL as a FQDN cache min-TTL because it deals with the FQDN. It's related to the cache. So, and so basically we set the FQDN cache min-TTL to so I'm sorry. So basically what happens is, so whenever a response is, the FQDN cache min TTL value is set in such a way that the detail that is received in the response of the DNS, it is compared as follows, as we have shown here. So if the cache mean detail value is higher than the response, then we use this value in the data path. So ultimately what happens is that the data path continues to be retained for a longer period of time, which is equivalent to the time which is set as the mean detail value by the administrator. And therefore it retains the data path for a longer period, therefore maintaining the communication which the pod tries to do. And also, this is a global configuration, so it applies to all the pods and it's not per pod, as well as it ensures the consistency across the pods. With potentially, they might have some different hard-coded values as we saw in the case of the Java application. And this is just a small screenshot that I took. This basically is from the Andrea.yaml. So this is how we can easily set it here. Um, and these are a couple of the PRs that we worked upon. And let me now quickly move on to the demo.
Before we do that, any questions on the problems that Emmett was solving? Okay, looks like you're good to continue.
Okay. So as part of the demo, we basically worked on the kind cluster. So I basically recorded the thing, and so I actually created a kind cluster here.
Emmett,
And
we're still seeing your browser. We're not seeing the video.
video.
Yeah.
Okay, 1 minute. Okay.
Yeah,
Is
you're
it
good
Good
now.
now.
okay? Great. So I basically am creating a kind cluster here. This is a video recording of it. I'll quickly forward this thing. And once the cluster was created, I created some Kubernetes resources, for example, the namespace and all. And then I actually, in order to, we created basically a dummy DNS server by using the custom DNS, and we exposed it as a cluster using cluster IP. I mean, as a service. So basically, I was just creating that as the DNS service, which would represent the custom DNS server. And so I once the custom core DNS service was created, this is the IP that we got, and this IP will be configured in the DNS server override setting, which is provided in Antrea for configuring the external DNS servers. So I'll be configuring this IP, and as you can see, had configured it in that Antrea.yaml. And I will all because we would also be needing an entry a toolbox pod, because we'll be trying to curl the FQDN from the toolbox pod. So the toolbox pod also need to be configured with the custom DNS server that we just created. So this is the deployment, and here I am um, setting up the DNS server here in the setting. So,
Eman, did you explain why you were creating a custom DNS service?
Yes, so basically we needed a DNS server basically to, to basically demonstrate this thing. So, and custom DNS service, basically what happens is once we create this service, the the cluster IP is allocated by the Kubernetes itself. So, because I needed to create this before deploying Antrea. So I will be having the IP of the DNS server because it is created as a the custom service, and then I'll be putting it into the Antrea.yaml.
I think what Anthony meant is the purpose of the custom DNS server, meaning that why do we need a custom DNS server rather than just using core DNS provided by Kubernetes?
Yes, so basically we needed a custom DNS server because one purpose was that we would be modifying the config map of their DNS server, and we would want this effect to be restricted within this namespace. And if we would have used QDNS, then basically it would have affected the cluster itself. And so basically we would be modifying the config map of of this DNS server with the IPs representing the FQDN.
Yeah, thanks. That's it. So that we can serve custom DNS records and with a custom TTL. Yeah.
Mhm. And so after configuring the DNS server setting, I am deploying the Antrea here. Okay, so the resources were basically configured. Now these were the agent logs that I was just showing this to ensure that things had started. And so next, now the setup is set up. For example, we have the Antrea agent running on the worker node and other things. So now I'll deploy the Nginx server, and this is the Nginx deployment. So basically, we are using Nginx here to we'll be mapping the IP addresses to the domain, and in the basically domain that we are using, the custom domain, we have mapped it into the Nginx servers basically. So we apply that resource, it creates the containers. Okay. So as you can see, we have two servers instances running and we got the IPs of them. So we'll be picking one of the IPs, which is this one, which is 10.244.1.4. And we'll be putting that in the config map. So basically, we had created the servers, but we have not created the custom DNS deployment yet. So I'll be editing this config map and adding the IP that we just saw, the 1.4, mapped against the custom domain. Antrea.lfx.test happens to be the custom domain. So I just changed that here. And now I'll be deploying the custom DNS server basically. So it deploys all the things. And here we can see the custom DNS service up and running. Next, I deploy the toolbox. And the toolbox was up and running, so the things were set up. And finally, I would be applying the entry and network policy, which has the thing. This is the network policy, which basically allows traffic to be forwarded from the pod to which. So basically, we can see that the policy will be applied to the Antrea toolbox by using the pod selector, and it will be allowing the traffic to the custom domain that we just created, and would be dropping all of the traffic. So okay, so the policy just got applied, and now I will be executing into the Antrea toolbox deployment. I mean Antrea toolbox pod, and we'll try to curl the domain. This is the domain. So okay. Yeah. So I just curled the domain and we have set up in such a way that we would be getting the hosting the pod as a response. So as you can see, we got this CQJLH something as a response, and we have the IP 1.4. So the 1.4 was the initial IP that we had set up in the DNS config map. And once we curl the domain, we get this corresponding host name, I mean corresponding uh, Nginx pods response. So move forward. Okay, and now just to imitate that the application has basically cached the IP and it has maintained the IP that it had received because of the DNS response in its own cache. So we'll be basically curling the IP from here on directly instead of the FQDN. So as you can see, once we curl the same IP, we got the same host name. So what I did was basically I just created a small loop here so that it keeps on curling it. And so what is happening here is that I put it in a loop, and after every 1 second, it is basically curling the IP that it has cached. Now, what we would observe is that after a certain point of time, wherein the Antrea agent basically refreshes its own the basically the DNS response that it had received, the Antrea will basically remove the data path rules related to this IP once I manually change the IP to another one. And because of that, what would happen is this communication will break because the IP had changed from the Antrea's perspective, but this app will continue to ping this, basically curl this IP. So this would break. So I'm editing the config map, and I will be using this new IP, which is 1.5. So as you can see, the agent basically, so as stated earlier, so the Antrea was able to pick, pick up that change. It removed the data path rule, and because of that, the pod basically failed to communicate with the FQDN further because it was using the same expired IP or the old IP in its cache. So this was basically the issue, the demonstration of the issue. Next, what we did was we will be configuring the FQDN, FQDN basically mean TTL in the Antrea.yaml. We will be applying it and recreating the agents. I mean, recreating the Antrea agents on the worker node again, and then we will see that the communication wouldn't break in after that. So I am, this is the Antrea.yaml, and here I have updated the value to 300 seconds just to demonstrate this. So this is basically somewhere around 5 minutes, and so we will see that it will continue to curl the IP for about 5 minutes instead of the previous case. So I'm just applying the Antrea.yaml again. It will take a while, and so basically, I was just ensuring here that the Antrea agents had restarted. So I'm just skipping this quickly. So what has happened now is we have restarted the Antrea agents have restarted after they have picked up the new configuration. We redeployed Antrea basically, and now the current configuration that we have is the 1.5 IP right now, and this is the corresponding domain. It is a different one. So basically, the config map of the core DNS, custom core DNS, has the 1.5 IP, and we will see that the application here is able to curl the domain, and we are getting this host name which corresponds to the 1.5 IP. And so I limited that the application is actually using its own cache instead of the FQDN, and I'll be putting that again in the loop as we did earlier. Mhm. This is the DNS setting that we have. It is 1.5. So I'll put this in a loop, and it will start curling the cached IP 1.5. And while it's doing it, then we will change the config map and set it to the another IP, which is 4, demonstrating that the DNS response was changed and the Antrea received a new set of IPs. So the new set of IPs were received by Antrea. And so what I'm trying to show here is basically that we have about 5 minutes time, which is set up as TTL. So in the earlier case, we saw that the data path rules had changed quite soon, respecting the time that we had set in the DNS response for about 5 or 10 seconds. But in this case, we will see that the application will basically continue to yes, and just to this was like I just wanted to show that in while we working on the mentorship, we basically also added the basically added the annotations of the DNS part so that it picks up the changes, because it takes a while as per the Kubernetes documentation. It takes a while to reflect the changes of the config map in the core DNS's file system. So I was just doing that. So as you can see that the application is still able to curl the IP, and we had started at around, if you look at the top screen, it was around 12:30, and it is still pinging and it will go on. So I'm just moving it forward, and you can see it is still able to curl it. So So at about after about 5 minutes, the time that we had set up, it has failed to curl, and respecting the min-TTL setting that we had globally configured in the Antrea. And down below, we can see that the Antrea agent logs also for the same. So this was it. And I mean, so this is how the min-TTL configuration that we set up is working, and it is serving the resolving issue. Thank you.
Thank you, Hemant. That was a very nicely done demo and very exhaustive. So, is there any question from the team? Waiting a few seconds. Okay, I'll go with possibly a stupid question, dumb question, you know. That's the I am a very expert in asking stupid questions. Anyway, in any case, my question is now we are introducing the option to configure a TTL for the cache. Is this an unbounded integer, meaning that you can specify TTLs as larger as you want? And in that case, do we think that maybe, let's say, especially in environments where there could be quite a bit of traffic, this could generate a lot of entries in the Antrea cache that eventually could pose an issue both like for memory usage and you know time required for doing lookups in the cache? I'm thinking, for instance, if you have a very long TTL of about 12 hours, then you can start getting a lot of entries in the cache, right?
Yes, I think if we set up a very large time, then that will indeed create a lot of entries in the cache. And so I think we'll have to discuss on the maximum value that we can put into it.
Okay. And I don't know if this is something that you already discussed with the mentors, but I mean, I was thinking that another mechanism could be putting a cap on the number of entries that we want to have in the cache, and then you know, like implement some algorithm for evicting entries from the cache when the cache is full. That could be probably another idea. I don't know if it can work or not. Just thinking of top of my idea.
Yeah, that actually sounds good to me. And yeah, we can probably pick that up.
Okay, thanks. And do we have any other question or comment regarding this? Okay, so question for the mentors, and this is completely just about my ignorance. Is the code already checked in Antrea code base, or is it planned for the next release?
I think out of the 3 PRs that Ement contributed, 2 have been merged, and 1 will be merged soon. And the feature is planned for the next release, which is Antrea 2.3.
Nice. That's very nice. Thank you, Anton.
Yeah, I think the hard part was actually writing an end-to-end test for this feature, and the end-to-end test that Ement wrote essentially does the same thing that he showed in this demo. So as the test itself is a bit complicated. The feature implementation wasn't that difficult.
Got it.
And yeah, I'd like to thank Hemant for doing his mentorship with us, and thanks for definitely improving the FQDN policy implementation in Antrea with those two contributions you made, that MinTTL feature and also an improvement to how we cache IPs in the Antrea agent.
Yes.
Uh,
Thanks a lot, Amand, for this. And okay, so your last question, this is your last chance to ask any question to Amand. Don't waste your chance. Come on. Anyway, jokes aside, it seems that this is all for the demo. So thanks again, Amand, and looking forward to see all the feature being released in the next Antrea release. And now we can move to other topics. As I said, we don't have anything booked in the agenda, so if there is anything that you would like to discuss, please go ahead. I'll wait as usual about 10 seconds. And that might be all for today. So thanks everyone for attending. Thanks again, Amant, for your demo, and we'll talk again in 2 weeks' time. Thanks, and yes, go ahead,
Yes,
sorry.
just a moment. I'm sorry. I just wanted to take this opportunity to thank Antonin and Shan and Yang. And I must say they've been really, really, really wonderful mentors to me. And thanks to the Linux Foundation on the and the community overall. And I definitely see myself as a changed person in terms of writing code and software engineering in general. And thank you all. Thank you so much for this opportunity.
Great, thanks for sharing this, Amant. And on these words, we can conclude today's meeting. Thanks everyone for attending, and I wish everybody a good afternoon, or a good day, or a good night. And see you in 2 weeks' time.
Thank you all.
Thank
Thank you.
you.
Bye.
Bye.
Bye-bye. Bye.